The purpose of the Telnet protocol is to provide a fairly general, bidirectional, 8-bit byte oriented communications facility. Its primary goal is to allow a standard method of interfacing terminal devices and terminal-oriented processes to each other. It is envisioned that the protocol may also be used for terminal-to-terminal communication and process-to-process communication. A telnet connection is a transmission control protocol connection used to transmit data with interspersed telnet control information. The telnet protocol is built upon three main ideas. One, the concept of a network virtual terminal. Second, the principle of negotiated options. And third is a symmetric view of terminals and processes. When a telnet connection is first established, each end is assumed to originate and terminate at a network virtual terminal or NVT. An NVT is an imaginary device which provides a standard network-wide intermediate representation of a canonical terminal. This eliminates the need for server and user hosts to keep information about the characteristics of each other's terminals and terminal handling conventions. All hosts, both user and server, map their local device characteristics and conventions so as to appear to be dealing with an NVT over the network, and each can assume a similar mapping by the other party. The NVT is intended to strike a balance between being overly restricted and being overly inclusive. The principle of negotiated options takes cognizance of the fact that many hosts will wish to provide additional services over and above those available within an NVT, and many users will have sophisticated terminals and would like to have elegant rather than minimal services. Independent of but structured within the Telnet protocol are various options that will be sanctioned and may be used with the do, don't, will, won't structured to allow a user and server to agree to use a more elaborate set of conventions for their telnet connection. Such options could include changing the character set, the echo mode extras. The basic strategy for setting up the use of options is to have either party or both initiate a request that some option take effect. The other party may then either accept or reject the request. If the request is accepted, the option immediately takes effect. If it is rejected, the associated aspect of the connection remains as specified for an NVT. Clearly, a party may always refuse a request to enable and must never refuse a request to disable some option, since all parties must be prepared to support the NVT. The syntax of option negotiation has been set up so that if both parties request an option simultaneously, each will see the other's request as the positive acknowledgement of its own. The symmetry of the negotiation syntax can potentially lead to non-terminating acknowledgement loops, each party seeing the incoming commands not as acknowledgements but as new requests which must be acknowledged. To prevent such loops, the rules that are prevailed are: parties may only request a change in option status. That is, a party may not send out a request merely to announce what mode it is in. If a party receives what appears to be a request to enter some mode it is already in, then the request should not be acknowledged. This non-response is essential to prevent endless loops in the negotiation. It is required that a response be sent to request for a change of mode even if the mode is not changed. Whenever one party sends an option command to a second party, whether as a request or an acknowledgement, and use of the option will have any effect on the processing of the data being sent from the first party to the second, then the command must be inserted in the data stream at the point where it is desired that it take effect. Option requests are likely to flurry back and forth when a telnet connection is first established, as each party attempts to get the best possible service from the other party. Beyond that, however, options can be used to dynamically modify the characteristics of the connection to suit changing local conditions. For example, the NVT uses a transmission discipline well suited to the many line at a time applications such as BASIC, but poorly suited to the many characters at the time applications such as NLS. A server might elect to devote the extra processor overhead required for a character at a time discipline when it was suitable for the local process and would negotiate an appropriate option. However, rather than being permanently burdened with the extra processing overhead, it could switch back to NVT when the detailed control was no longer necessary. It is possible for requests initiated by processes to stimulate a non-terminating request loop if the process responds to a rejection by merely re-requesting the option. To prevent such loops from occurring, rejected requests should not be repeated until something changes. Operationally, this can mean the process is running a different program or the user has given another command or whatever makes sense in the context of the given process and the given option. A good rule of thumb is that a re-request should only occur as a result of subsequent information from the other end of the connection or when demanded by local human intervention. As much as possible, the Telnet protocol has been made server to user symmetrical so that it easily and naturally covers the user to user and server to server cases. It is hoped but not absolutely required that options will further this intent. In any case, it is explicitly acknowledged that symmetry is an operating principle rather than an ironclad rule. Network Virtual Terminal. The Network Virtual Terminal, that is NVT, is a bidirectional character device. The NVT has a printer and a keyboard. The printer responds to incoming data and the keyboard produces outgoing data which is sent over the telnet connection, and if echoes are desired to the NVT printer as well. Echoes will not be expected to traverse the network. The code is set 7-bit US ASCII in an 8-bit field, except as modified herein. Any code conversion and timing considerations are local problems and do not affect the NVT. Transmission of data. Although a telnet connection through the network is intrinsically full duplex, the NVT is to be viewed as a half duplex device operating in a line buffered mode. That is, unless and until options are negotiated to the contrary, the default conditions pertain to the transmission of data over the telnet connection. 1. Insofar as the availability of local buffer space permits, data should be accumulated in the host where it is generated until a complete line of data is ready for transmission, or until some locally defined explicit signal to transmit occurs. This signal could be generated either by process or by a human user. And second is when a process has completed sending data to an NVT printer and has no queued input from the NVT keyboard for further processing, the process must transmit the telnet go ahead, that is GA, command. Standard representation of control functions. As stated in the introduction to this video, the primary goal of the Telnet protocol is the provision of a standard interfacing of terminal devices and terminal-oriented processes through the network. Early experiences with this type of interconnection have shown that certain functions are implemented by most servers, but that the methods of invoking these functions differ widely. For a human user who interacts with several server systems, these differences are highly frustrating. Telnet therefore defines a standard representation for 5 of these functions as described here. The standard representations have standard but not required, meaning that is a system which does not provide the function to local users need not provide it to network users and may treat the standard representation for the function as a non-operation. On the other hand, a system which does not provide the function to a local user is obliged to provide the same function to a network user who transmits the standard representation for the function. Interrupt process, that is IP. Many systems provide a function which suspends, interrupts, aborts, or terminates the operation of a user process. This function is frequently used when a user believes his process is in an unending loop, or when an unwanted process has been inadvertently activated. IP is the standard representation for invoking this function. It should be noted by implementers that IP may be required by other protocols which use Telnet and therefore should be implemented if these other protocols are to be supported. Abort output, that is AO. Many systems provide a function which allows a process which is generating output to run to completion but without sending the output to the user's terminal. Further, this function typically clears any output already produced but not yet actually printed or displayed on the user's terminal. AO is the standard representation for invoking this function. For example, some subsystem might normally accept a user's command, send a long text string to the user's terminal in response, and finally signal readiness to accept the next command by sending a prompt character to the user's terminal. If the AO were received during the transmission of the text string, a reasonable implementation would be to suppress the remainder of the text string but transmit the prompt character and the preceding CRLF sequence. Are you there? That is AYT. Many systems provide a function which provides the user with some visible, example printable, evidence that the system is still up and running. This function may be invoked by the user when the system is unexpectedly silent for a long time because of the unanticipated length of a computation and unusually heavy system load X extras. AYT is the standard representation for invoking this function. Erase character, that is EC. Many systems provide a function which deletes the last preceding undeleted character or print position from the stream of data being supplied by the user. This function is typically used to edit keyboard input when typing mistakes are made. EC is the standard representation for invoking this function. Erase line, that is EL. Many systems provide a function which deletes all the data in the current line of input. This function is typically used to edit keyboard input. EL is the standard representation for invoking this function.